Today's video I'll be making for a Patreon member and friend of mine who also belongs to the same project that I help to administer. He shares a lot of subclades with the last video that I made, so you're going to see certain similarities between both videos. His current terminal subclade is I-FT220816, which dates to approximately 1787 CE, according to family tree DNA age estimates. Now, I believe that this subclade originated in the American colony of Virginia, and I'll go more into that later on in the video. His earliest known patrilineal ancestors can trace back to the town of Warrington in England prior to arriving in the American colonies. People such as my friend that have English ancestry and are positive for haplogroup I1 often want to know, did their patrilineal forefathers arrive to the region with the Anglo-Saxons or later on with the Vikings? In this video, using ancient DNA evidence, I'm hopefully going to provide compelling evidence that the answer to that question is the Danes during the Viking Age. A new preprint was recently released titled Steppe Ancestry in Western Eurasia and the Spread of the Germanic Languages. In this preprint, there was a lot of interesting information regarding the origins of the Anglo-Saxons. To quote the preprint, quote, "Here we find almost all samples from England fall within the southern Scandinavian clusters, restricting the range from the Netherlands to Jutland," end quote. To further quote the preprint, quote, "We can now reject the Danish Isles and Sweden as a source area for the Anglo-Saxons in Britain," end quote. Based on the aforementioned information, if my friend's patrilineal forefathers were Anglo-Saxons, I would expect them to find some ancient DNA evidence in the areas shaded in the following map. But when I analyze my friend's subclades, going all the way back to the Bronze Age with subclade IS-26361, I find zero ancient DNA evidence that can be associated with the Anglo-Saxons, both in continental Europe and in England itself during the early Middle Ages. In 2022, there was a very important study that was released titled The Anglo-Saxon Migration and the Formation of the Early English Gene Pool. Out of all the ancient DNA locations that you can see in the following image from that study, there were zero ancient DNA samples that can be associated with my friend's subclades, starting all the way back to the Bronze Age with IS-26361. Let us now take a look at the ancient DNA evidence for these same subclades for my friend that can be associated with Viking Age Denmark. In the following map, the Danish island of Zeeland is also referred to as Zealand or Sealand, and the island of Finn is also referred to as Funen. So it depends on what language you are speaking. My friend's first ancient DNA connection comes from the 2020 study, Population Genomics of the Viking World. The ancient DNA sample is labeled Craig Have 532 in the family tree DNA database. He's also known as VK532. He lived sometime during the Roman Iron Age between 1 and 200 CE. He was discovered in Craig Have Odif Tofter on the island of Sealand in Denmark. He connects to my friend through the Bronze Age subclade IS-26361. The next ancient DNA connection also comes from the 2020 study, Population Genomics of the Viking World. This sample is labeled Tola 71 in the family tree DNA database. He's also known as VK71. He lived sometime between 700 and 1000 CE. He was discovered in Tola on the island of Sealand in Denmark. He connects to my friend through the late Bronze Age, early Iron Age subclade IS I-FT220816. The third ancient DNA connection comes from the 2024 study, Elevated Genetic Risk for Multiple Sclerosis Emerged in Steppe Pastoralist Populations. The sample is labeled Algade835 in the family tree DNA database. He lived sometime between 1350 and 1400 CE. He was discovered in Holbæk on the island of Sealand in Denmark. He connects to my friend through the subclade I-FT220816, which dates to the pre-Roman Iron Age. Lastly, my friend's closest ancient DNA connection also comes from the 2020 study, Population Genomics of the Viking World. The sample is labeled Galgadil LS in the family tree DNA database. He's also referred to as VK446. He lived sometime between 800 and 1100 CE. He was discovered in Galgadil on the island of Funen in Denmark. He connects to my friend through the subclade IBY19383, which dates to the Roman Iron Age. This archaeological site was also mentioned in a 2014 research article, Galgadil, Isotopic Studies of a Viking Cemetery on the Danish island of Funen, AD 800 to 1050. You can see in the following map from that research article that the archaeological site of Galgadil is located in the north of Funen Island. Galgadil LS is grave labeled LS, which is in the far right-hand area of the middle blue region. So all four of my friend's closest ancient DNA connections come from the Danish islands. And I just want to reiterate what the recently released preprint wrote about this subject matter. Quote, "We can now reject the Danish Isles and Sweden as a source area for the Anglo-Saxons in Britain." End quote. I feel that evidence, combined with the fact that there is zero Anglo-Saxon ancient DNA evidence, leads me to conclude that the most likely explanation for my friend's patrilineal forefathers entering the region of England would be in association with the Danes during the Viking Age. My friend has two other interesting patrilineal connections with the IBY19383 subclade, which dates approximately to 214 CE. The first interesting connection is that he shares this branch with yours truly. Yes, everything mentioned in this video up to this point applies to my own patrilineal line as well as to my friends. I believe that our patrilineal lines diverged apart somewhere in the Danish Isles after this subclade. My friend also shares the IBY19383 branch with the famous Roosevelt family. I believe this patrilineal divergence occurred in the Danish Isles as well, with the Roosevelt patrilineal line eventually emigrating to the Netherlands, and my friend's patrilineal line eventually emigrating to England. One might ask, if my friend's patrilineal forefathers were in the Danish Isles leading up to the Viking Age, why don't we find modern Denmark matches in the database? Why don't we have people claiming Denmark for the earliest patrilineal country of origin that are also positive for the subclades leading up to the Viking Age? And I can think of three possible reasons why. First, as of April 11, 2024, in the family tree DNA database, only 847 Y chromosome testers have claimed Denmark for their earliest known patrilineal country of origin. So it's theoretically possible that my friend does have these subclade matches for those subclades leading up to the Viking Age that do currently live in Denmark but just haven't tested yet. Another possibility is all evidence for a Danish Isles origin for these subclades leading up to the Viking Age emigrated away from the Danish Isles during the Viking Age. Lastly, you could have a scenario where there was evidence, there were people living in the Danish Isles after the Viking Age who were positive for these subclades, but over the past 1,000 years, over the past millennia, those patrilineal lines died off and do not have any patrilineal descendants living today. If either scenario 2 or 3 is correct, then we're not going to find any modern testers positive for the subclade living in Denmark or claiming Denmark for their earliest known patrilineal country of origin today. Now, my friends, closest in time subclade to the Viking Age is branch I-FT220816, which dates approximately to 811 CE. Now, age estimates are called estimates for a reason. They're not to be taken as exact fact. So this date is so close to when the great heathen army entered England, around 50 years later, I think it's entirely possible this branch could have originated in England. If not, my next best guess would be slightly prior to the Danes moving westward, somewhere in the Danish Isles. Now, there is quite a large time gap of missing data between when the great heathen army entered England and when my friend finds his earliest known patrilineal ancestors in the 1500s in the town of Warrington. Warrington is currently situated in the region of Cheshire, England, which is the area shaded in red in the following map. But that region used to be part of the historic region of Lancashire. Eventually, my friend's patrilineal forefathers would emigrate to the New World, to the American colonies in the 1600s, and one of these patrilineal forefathers would enter the colony of Virginia in the 1700s. This is where and when I believe my friend's terminal subclade originated. This subclade is very interesting and hard to piece together. So far, there are 5 individuals who have tested positive for this branch, and they have 3 different surnames. My friend has his surname, and he has 1 private variant since this branch formed. Another individual has a different surname, and he also has a private variant since this branch formed. However, he does share the same patrilineal ancestor with my friend who was born in 1785 CE in Virginia. So we know that they both can connect at that point. And this date is very close to the family tree DNA age estimate of 1787 CE. That being said, though, surname number 3, which has 3 individuals who have tested positive for this branch, one of them can also trace their earliest known patrilineal ancestor to Virginia to the late 1700s. So I don't think this individual born in 1785 is the common patrilineal ancestor for all of them. Rather, I think the common patrilineal ancestor was probably his grandfather, who entered the region of Virginia in 1745. Now, how all of this patrilineal divergence took place, I don't know. What's really interesting is that none of these 5 testers share any private variants since this common patrilineal ancestor. And that was really surprising to see for surname group number 3. So I'm guessing that all of this patrilineal divergence for all 5 of these individuals must have happened within just a few generations. That's the only way I can understand that none of them share any further downstream SNPs. What else can we learn from my friend's STRs? Well, overall, he has a slow to average STR mutation rate. What are some of his promising leads? Well, Y111, he has a genetic distance of only 5 match. And this person has a completely different surname than the other 5 individuals that have already tested positive for his terminal subclade. So we might be looking at surname number 4 for this branch. I think he should definitely pursue getting this person upgraded to Big Y700 so we can see that they are also positive for I-FT220816, or maybe they'll break up that branch because he connects slightly prior in time. My friend also has a Y67 genetic distance of 2 match who shares that same 1785 common ancestor. However, he has a completely different surname as well. So we're looking at surname number 5 possibly for this one branch, which is the most surnames that I've ever seen for a genealogical time frame match. So I find that really interesting. Now, he has plenty of Y67 and Y37 matches. And maybe one of them, might fill in some subclades during that large time gap of missing information between his current terminal subclade and its parent subclade. That being said, though, because he has a slow to average STR mutation rate, it's hard to know for sure because convergence and a lack of divergence could be at play for these Y67 and Y37 matches. So there's no guarantee that any of the results, should they upgrade to Big Y700, will shed more light or add new subclades for my friend's direct paternal line. Thanks for watching.